So today's topic in this video is Lorentz force. Lorentz force means it is a combination of electric and magnetic force. That means suppose a charge is in an electric field as well as in a magnetic field, then the charge will experience a total force which will be the net force of electric force and magnetic force. So that combination, that net force, this one, that is called Lorentz force. Means it is a summation, it is a vector sum of electric force and magnetic force. Okay. Suppose electric force, the expression we have this one, Fe means Q into E, where E is the electric field, Q is the charge of the object, and then magnetic force, in last video I told you about it, Fm is equals to Q into V cross E. So the net force will be magnetic force, electric force QE plus magnetic force QV cross B. Q, if you take common, then the thing becomes like this, E plus vector E plus vector V cross B. So this as a whole is the Lorentz force. Okay. Now suppose we know that the force can be expressed in this form by this formula, but this formula can be modified for a conductor. Suppose here we have a conductor. Just a second, too much of noise outside. Anyways, this one, there is a conductor. Okay, through this conductor I current is flowing. Suppose I current is flowing means the flow of current and flow of charge is same, right? So how much charge is flowing? Electrons are flowing, the charge will be E. So for these electrons, the force should be like this, F is equals to Q into V cross B. Q means it is E, charge of electron, into V cross B. Now what we have done here, we have done little modification by multiplying this V with time and dividing E by time. We can do it, ultimately we will get the same equation, this one. Okay. Now charge by time gives us current. This is the current which is flowing through the conductor, and V into T is nothing but the distance. So these electrons, how much distance these electrons are moving? Nothing but the length of the conductor. So that is why Vt I have written L. Okay. So the force formula becomes I into L cross B. This is for conductors, where the length of conductor is L, I is the current flowing through the conductor, and B is the magnetic field within which the conductor is kept. Alright, the conductor is within a magnetic field of how much intensity? B. Now here, since it is cross product, we know that A cross B means AB sin theta, right? A cross B, that is equal to what? AB sin of theta, where theta is the angle between A and B. Similarly, L cross B means it should be LB sin theta, I will remain as it is, and theta is the angle between L and B. Alright. Now see, if theta is 90 degree, sin 90 is 1, then the magnetic force becomes the maximum, which is ILB, maximum force. And if theta is 0 degree or 180 degree, sin 0 is 0, sin 180 is also 0. So as a result, the whole force becomes 0. That means if this conductor is parallel or anti-parallel to magnetic field, parallel means when it is 0 degree, anti-parallel means when it is 180 degree, then the force on this conductor will be 0. And when it is 90 degree, then this will be maximum, which is ILB. Okay. Then here in next topic, we will discuss charged particle moving in an uniform magnetic field. Depending upon the orientation of the charged particle in a magnetic field, or the direction of charged particle in a magnetic field, the charged particle undergo different path. Like sometimes it follows circular path, sometimes spiral path. So we will see that under which condition what type of path is followed by those particle in the next topic.